At the top of your page, could you go ahead and draw two triangles? Now, don't draw it too small. You can draw it a little bit bigger. So go ahead, draw yourself these two triangles. And I would say these two triangles would be particularly meaningful for some of you if you are taking the SAT this Saturday. Is it this Saturday? Okay. Do you know what we call these two triangles? Special right triangles. And how special are they? This is the 30, 60, 90 degree triangle, and this is the 45, 45. Okay. Now, I'm going to label the shortest side as S. I'm going to ask you now. I'm going to ask you to label these sides. Okay, label these sides properly. I hope you do know how to label them. If you're taking the SAT this weekend, I think there will be about 1 to 2 questions every year. Everyone, not every year. Every single SAT test, they will have 1 to 2 questions related to special right triangles. Okay. How many of you know how to label these sides? Nobody? 1, 2, 3? Well, let's start with this one. This one is easier. What's the bottom side? Because it's a what kind of triangle? How do you know it's an isosceles? 2 angles are the same, right? So so it's an isosceles triangle. And how do you figure out the hypotenuse? Your good old Pythagorean theorem. A squared plus B squared equals to C squared. So, well, since A and B, they are both S, so you have S squared plus S squared. Well, to find out C, you gotta take a square root. So that's why you have square root of 2S squared. And that's why you have S root 2. So we label this S root 2. Now it's very relevant to what we are doing today. So, so if you wonder, what are we doing this? It's because it's relevant. Okay. So S root 2. And for the 30, 60, and 90 degree triangle, the hypotenuse is 2S. And the base side right here is S root 3. S root 3. Any question about these labeling? All right, now, if you don't have any question, then below each triangle, I want you to write the following things. I want you to write down for the left, for the 30, 60, 90 degree triangle. I want you to write down sine of 30. Okay. Oh, this is a fraction line, by the way, because you have a ratio. What's the ratio for a sine function? Opposite of a hypotenuse, right? So so I want you to go ahead and take a look at these angles and obtain these ratios. So you focus on the 30 degree angle, and then you focus on the 60 degree angle. And then for the right-hand side, you will focus on the 45-degree angle. Now, just to get you started, in case you you might be a bit puzzled. So if you look at sine 30 degrees, so that means we're looking at 30-degree angle right here. What is the opposite side of the 30-degree angle? S. And the hypotenuse is 2s. So therefore, if you reduce it, simplify it, you have the ratio of 1/2. Okay, so so go ahead, take a minute or two, and work out all the ratios for these trig functions. Take one passage down. Do not put any food on the paper plate. All right, so what's cosine of 30 degrees? It'll be s√3 over 2s, which becomes √3 over 2. Sine of 60, so you look at the 60-degree angle. What's the opposite side of the 60-degree angle? s√3. Hypotenuse is still 2s. Any question about how we obtain these sides? Because when I was a kid, it took me a while to realize that which is the opposite side, which is the adjacent side. And when we switch the angle from 30 to 60-degree angles, we actually talk about different focus. So cosine 60, adjacent side would be s, hypotenuse 2s, so it is 1/2. And for sine 45 degrees, you have s over s√2, which is 1 over square root 2. Can we leave the square root in the denominator? You cannot do that, so therefore you have to rationalize it, and that's how you have √2. So you have to multiply by 1, but in the form of √2 over 2. And that gives you √2 over 2. And then sine 45 degrees is also s over s√2. That means it would end up to be the same thing, square root 2 over 2. Okay? Good. Now, just a quick reminder. Okay, I know we talked about this a few days ago, but I do want to remind you. Now, the reminder I would like you to have is this. The reminder is that, what is it? The reminder here, it's unit circle. For unit circle, remember the unit circle, what's so unique about the unit circle again? The radius is 1, right? And the radius happens to be the hypotenuse. So if you remember the unit circle, hypotenuse is 1, and this is our theta. So opposite side, it's our y, and adjacent side, it's our x. And we said that x is equal to cosine theta, and y is equal to sine theta. Okay, because cosine theta is adjacent, which is x over 1. So that's why x is equal to cosine theta. And y is equal to sine theta because sine theta is opposite, which is the y side, over 1. Okay? All right, so are we good? So you got a paper plate. Huh? What's that? Okay. Yeah, so what we are going to do is this. You got a paper plate. And the paper plate is for you to fill out this unit circle. Yes. Okay. So now what you would do is this. You can work in groups and you are going to cut out the circle. And there are some blanks for you to fill out. Now I have some number of scissors and limited amount of glue sticks. So you have to take turn. But you have the rest of the class period to do this. So let me go ahead and hand this out to you first so that you can at least try putting something onto the paper. Yeah, you should orient the circle this way. The box is on your right-hand side. Okay. Now, so I want to do first write down a few things so that you can tell the at least you can tell the angles. So over here, can you see the degree sign? So if you have the degree sign, please go ahead and write down 0 degree. And then the blank right next to it is for you to write down the radian, and that will be 0 radian. Okay. So again, it should be right next to the white box right there. Okay. Now, since the radius it's 1, can you tell the coordinate pair of this point? It's going to be 1, 0. Now, you would do this point not on this paper. You would do this point on the paper plate. I'm just asking you if you know it. Okay, so you do this point on the. So this is going to be on your paper plate. Okay, you're going to cut out the circle. You draw the coordinates on the paper plate. Now, what about the other degrees? This will be 30 degrees. What is the radian measure of 30 degrees? Pi over 6. Very good. The next angle will be 45. The radian measure is pi over 4. And after 45 degrees, you have 60 degrees. And the radian measure is pi over 3. At the very top, you have 90 degrees, and the radian is pi over 2. Okay. Now, one thing I really want you to see is symmetry. Symmetry to the left, symmetry to the bottom. Okay. So, so what about these angles? Well, you know what this angle is. It must be 180, and the radian would be pi. All right. Now, what about these 3 angles? Well, this is 30 degrees, right? So this will be also 30 degrees. So it'll be 150, 135, and 120. Okay. So I'm going to let you write out these angles. Okay. But now, I want you to do something real quick. Now you can remind yourself, well, actually, I hope you wrote down this one, the unit circle. X is equal to cosine theta, and y is equal to sine theta. Okay, you can look at that on your piece of paper. And what I want you to do is this. Now, I'm going to show you first, and then you're going to do this on your paper plate. So you can go ahead and draw yourself a little triangle, okay, a right triangle. Okay. Now, I want you to know when we say 30-degree angle, this is the 30-degree angle. And the reason why we said cosine theta is equal to x, or x equals to cosine theta, because now, if you want to fill out the coordinate of this point right here, the x value of this coordinate, it's going to be cosine of 30. Because it is this length right here, cosine of 30. And you look at your own paper, what's cosine of 30 degrees? It is √3/2. And then we look at the y value. The y value is sine of 30. Sine 30 is 1/2. So that's why I asked you to write out all those ratios, because now you have an easier time to just match the coordinates. And you look at the 45-degree angle, or you look at the 45-degree right triangle. Okay. Let me go ahead and change another color. Okay. So cosine of 45 is √2/2. And sine of 45, it's also √2/2. Okay. And then for the 60-degree angle, so if you want to create a little triangle again, then we say, what is cosine of 60? It's 1/2. And then sine of 60, it's √3/2. And then at the top, you have 0, 0, 1. Okay. So that's why I asked you to write out, well, I asked you to draw the special right triangle, asked you to do the ratio, because I need to make sure that you know the justification of these numbers. Now, what happens if you need to do the coordinates of these values? So if you look at these values, and then you have to write down these values, what coordinate would remain the same for these values right here? What coordinates shall remain the same? The y values, right? And what will be negated? The x value, right? Now, if you look at these values down at the quadrant 4 compared to the quadrant 1 values, what coordinate is being negated? The y value, right? But x value remains the same, because in terms of the x value, they are exactly the same. And what about the values in quadrant 3? Both are being, right? Both are being negated, right? So go ahead. You can pull the chairs together, work in groups, and then cut out your circles. so that you can draw the coordinate pairs on the paper plate. Yeah, I only have 2 glue sticks. I think there's one more over there. Is it? Or did I take it away already? Is it there? Oh no, I took it away. So yeah, if you have your own, great. If you need it, just come over here, help yourself. All right, now, so I hope you're about done with all these cutting and gluing. I want to make sure that you can work out these values very quickly. Okay, and I want to point out all these angles so that you know how to get these angles very quickly. Now, I want you to focus on the idea of symmetry. Okay, so these are going to be about the same. What about the number in the numerator? After you convert it, you will see that it is always 1 less than the denominator. Did you see it? And for the one in quadrant 3, what did you discover? It's 1 greater than the denominator. And of course, there's a reason behind it. And then over here, we have these are pi over 6, pi over 4, pi over 3. And for these numbers, they are 1 less than 2 times the denominator. Now, that's a reason. Do you know what the reason is? How'd you get this? Well, this angle is 30 degrees, right? Which is pi over 6. And to go in negative direction, right? So it's thinking about 2 pi minus pi over 6. And once you get the common denominator, 2 pi becomes 12 pi over 6. That's the reason why it's 11 pi over 6. Okay? So we'll get into that more in detail later on. Now, what about the values? Now, one thing that you should be able to see very clearly, it's the 1/2. Okay, you can say, oh yeah, I can tell where it's 1/2. Like this, the green one, it's 1/2 of the x-axis, or 1/2 of the radius, right? So at the very least, you can, well, that's not good color. You can write out the 1/2 here. You can tell the y value is 1/2. And can you tell all the denominators are 2? And can you see the numerators? They're like 1, 2, and 3. 1, 2, 3, right here. 1, 2, 3, 1, 2, 3. So if you want to just fill out the values, you can actually make use of these patterns. Okay. So over here, I will be able to write down that this is, this is 1/2. And this is negative 1/2. So if you want to just fill out the circle, you fill out the coordinate pairs. If you know where it's the 1/2, you can basically continue with the writing. 1, 2, 3, 1, 2, 3. Okay. And the endpoints are going to be -1 and 0. So right here, hold on. right here. This is the x being negative 1/2. So and what you would also know is that if one is square root 3/2, the other one must be 1/2. So I want you to see this kind of pattern to check yourself. And of course, if you rely on this pattern, then you must make sure your very first point must be absolutely accurate. If you start the first point wrong, the whole thing went messed up. Okay. So this is 1/2. That means this must be root 3/2. The middle one, it's always root 2/2 because it's 45-degree triangle. And then, oh, my bad, it's a negative y value. Okay. So try to utilize pattern. Now, if I remember correctly, there will be a quiz on this. And if I remember correctly, we'll just hand you a blank unit circle, just like this, and you fill out all the blanks. That's a quiz. I think you have 10 minutes for that. Okay? You have 10 minutes for filling out all the blanks. Now, if you receive that piece of paper and you say, let me figure it out, then you have a lot to figure out. Because you should not have the paper and figure out. You should have figured it out already, and you get the piece of paper, you just start writing. Okay? So if I were you, I would go online, just Google search, unit circle, and start practicing. Okay? Just start practicing. I think the next quiz is next week, not this week, but next week. So I will also make a video to show you how I learned these trigonometry without the unit circle. I never had unit circle in my life until I started tutoring math 13 years ago. So, so there's a way to do it without the unit circle. And I will let you choose whichever way you want to, but there are options. There are options you can choose to do things. Okay, so make sure you bring in the paper plates tomorrow and every single day for next week, for this week and next week.